Let's let P and Q be the number of faces on our two dice. So with our first die, we can roll any integer from 1 up to P, and with our second die, we can roll any integer from 1 up to Q. And the problem tells us that P and Q are both greater than or equal to 6. Let's see how many ways we can create a sum of 7 by rolling our two dice. Listing them out, we see that there are 6 ways. So the probability of rolling a 7 with our two dice. For our first die, we have 6 possible rolls out of P possible faces. And for each of those rolls, we have 1 possible dice roll for our second die. And that's out of Q possible faces for our second die. So this probability is 6 over P times Q. We are given that the probability of rolling a sum of 7 is 3/4 times the probability of rolling a sum of 10. Let's let n be the number of ways to roll a 10. So the probability of rolling a 7 is 6 over P times Q. And if there are n ways out of P of rolling half of our sum, then that leaves us 1 out of Q to complete the sum of 10. So this is our equation. We can multiply both sides by P times Q and solve for n. So the number of ways of rolling a 10 is 8. We'll hang on to that for later. Our next bit of information is that the probability of rolling a sum of 12 is 1 over 12. Let's experiment for different values of P and Q. So for example, if both of our dice have 6 sides, the only way we can generate a 12 is if we roll a 6 on both of them. That's one way out of a possible 36 different rolls. If we have one die with 6 sides and another die with 7 sides, we can generate a 12 with a 6 and a 6, or a 5 and a 7. That's 2 out of 36 ways. If both of our dice have 7 sides, we can generate a sum of 12 with a 6 and a 6, a 5 and a 7, or a 7 and a 5. That's 3 out of 36 ways. If you keep experimenting with values of P and Q, you'll see that every time you increase one of P or Q by 1 additional face, you increase the numerator of our probability by 1 as well. So let's generalize for all values of P and Q. Our numerator is P plus Q minus 11 because this varies linearly with P and Q, the number of faces on our two dice. And our denominator is the product of P and Q. So we want P plus Q minus 11 over PQ. The probability of rolling a 12, we want that to be equal to 1 over 12. Let's multiply by the denominators and collect the terms. This looks like a job for Simon's favorite factoring trick, so we'll factor out P. To get a matching factor, we need to add 144 to both sides. Factoring once more, we have the product of two integers equals 12. Here's our usual candidate of factors, but we want to minimize the sum of P plus Q. So we need to also look at the negative factors. We quickly eliminate -1 and -12 because that gives us 0 faces for one of our dice. So let's try -2 and -6. We'll solve for P and Q. Now recall, we need to have 8 ways of making a sum of 10. I count 6 ways here, so this isn't a valid solution. Let's try our next pair of factors, -3 and -4. Our second die can roll as high as 8, and we see that there are indeed 8 ways of generating a sum of 10. So this is our valid solution. The problem asks for the sum of our two faces. That's 17, which is option B.